Okay, everybody, let's do a recap of what we learned. So, in today's lesson, and out of our book, we talked about things called linear piecewise functions. So, what is a linear piecewise function? So, we had a couple of examples of those in our big packet of graphs, or cutouts. So, like the word says, they're pieces of graphs. So, for instance, A is like 1, 2, 3 different pieces. And they are linear because they're straight. So it's a piecewise graph because there's 3 different pieces. We had one more of those right here. This is a linear piecewise graph because there's 1, 2 different graphs together to make one graph. So 1, 2, that's a piecewise linear graph. So then I give a definition. So it says basically one more than more than one line together on a graph. Okay, that's kind of a rough definition, but it'll work for today. So I'll give an example. Here's a horizontal with a vertical, right? And then I showed another. They don't have to necessarily connect. They just have to be 2 pieces. Now, one of the things also we talked about was this. This graph, this horizontal graph, does not go all the way across. It does not go all the way across because if it did, it wouldn't be a function. It wouldn't be a function. So we can only have part of it. Same thing with this graph. This line right here does not go all the way around like that because if we had the whole thing, again, it wouldn't be a function. So we only want certain pieces out, okay? This graph is from x is less than -1, and this one's from x is greater than -1, okay? Now, in our book, we had 2 different examples. The first one was f of x equals a -2, f of x equals 1/2 x minus 2. And the second example we had was f of x equals a -2x plus 10, f of x equals 4, and f of x equals a -2x plus 18. So then we talked about how many pieces. This graph is going to have 2 pieces because of the 2 equations. We had talked about how f of x and y mean the same thing, so I wrote my 2 pieces. Y equals -2, graph 1. Y equals 1/2 x minus 2, graph 2. Now we'll talk about this in just a bit, okay? Now, graph 2 has also 3 pieces. F of x and y are the same thing, so we have a y equals a -2x plus 10, we have a y equals a 4, and a y equals a -2x plus 18. And again, we'll talk about this in just a second, okay? So here's our 2 pieces and our 3 pieces. Now, I wanted to graph these, so I actually got out a piece of graph paper, and what I did is I started graphing these. So I rewrote these on a piece of graph paper. I said, okay, let's do the first one, okay? So what we did is we started with just what I said. F of x and y are the same thing. So I wrote my 2 pieces. Y equals -2 and y equals a 1/2 x minus 2. Now, I know how to graph y equals -2. That's all the way across. Okay, so I did that first. I graphed that. But I didn't want all of that. Now, here's where the boundaries, these are called the boundaries. Here's where the boundaries are. So right at x equals 0 is our boundary. This is called our boundary point, okay? These are boundary lines. My graph y equals -2 is supposed to be less than 0, so I did not put the entire graph in. I only had this part of it. My second graph, y equals 1/2 x minus 2, I'd start at -2 because that's my y-intercept. Go up 1 over 2, up 1 over 2, up 1 over 2, and I'd graph it in. But I did not graph all of this. First of all, it wouldn't be a function. I only graphed the part that was greater than 0, okay? So that's my first graph. Now the second graph, which we're going to look at, has 3 pieces. So let me turn this page. And our second graph out of the book has 3 different pieces. Now remember, y and f of x mean the same thing, right? So the first piece would be y equals a -2x plus 10. The second piece is y equals 4. My third piece is y equals a -2x plus 18, right? We'll have to graph these. But before I graph these, I'm going to go to my border lines because it's going to help me. I know I'm going to have 3 pieces, and my 3 pieces have to be in different areas. So, x-axis, I drew an invisible line. Of course, you can see it at x equals 3. I drew an invisible line at 7, so I have my boundaries. I have a region here, I have a region here, and a region here. Okay. So then I graph my first line. I started way up at 10. I went down to a 1, down to a 1, down to a 1. And normally the graph would go all the way through like this, but this first graph is only less than 3, so it's in this boundary. I erased all the rest of this. Only this piece. Second graph, y equals 4, goes across horizontal like this. But I don't want the whole thing. I only want the piece in between 3 and 7. And finally, this graph starts at positive 18, which is way up here. Positive 18. Not on the invisible line. Do not start on the invisible line. This is the number one mistake kids make because they graph on this line. But on the y-intercept, even though I'm going to erase it, I will erase it, I still have to start at 18. I went down 2 over 1, 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 and I just graph this in. But I only want the part of the graph which is on this region. X is greater than or equal to 7. So then I erased all the rest of that. So we talked about graphing these. You guys will not have to graph these in homework, but it might be an extra credit question on the test. So I gave homework. The homework today was a worksheet. And it was these problems. I wanted you to identify the type of graph: exponential, linear, piecewise, quadratic, so forth and so on. And I also wanted to state domain and range. Then I gave the kids one extra little question. I said, if you can do this, just try to see if you can graph that. So that was today's lesson. If you have any questions, come see me. I'll be here.